So let's knock out 5, 6. Like I said, it's pretty much a review from yesterday. A little bit more to it. So you don't need your Chromebooks just yet until we do calculator stuff here in a little bit. All right, so when you think of something that's like the fundamental theorem of algebra, you think it's going to be like the biggest thing ever. It's literally what we talked about yesterday. If it is raised to the 5th power, it's going to have 5 roots. Ooh, okay. We already talked about that yesterday. That includes multiple roots, complex roots, real roots, all of them, okay?
Imagine this being your life's work.
Huh?
Imagine this being your life's work. Like you sit down and you're like, I'm really going to think about this for a second. I'm going to figure out,
right?
Yeah, understand a lot of math, and this is my life.
Right. I had to take history of mathematics in college. Talk about a class that is A, very boring, and B, one of those y'all like to say, when am I ever going to use this again? That's one of those classes. But we went through why and who and how these mathematicians came up with certain things. Then it was, of course, at UT. And
Which one?
UT. And it was up on top of Ayers Hall, the tower building y'all see on like everything. I'm not that old, but it had no air conditioning. Okay. So, and this sounds so like grandma-ish, but I had to go to school uphill both ways kind of thing. But it's called the hill for a reason. It's literally on top of the hill. And so you'd get up there, by the time you get up there, you're sweating and whatnot. And it was in the middle of summer. And then I had to sit there and learn about mathematicians. The most miserable class. Well, majority of the classes I took were miserable. When your prerequisite to get into a degree is Calc 3, and then after that, talk about never using something ever again. One of my analytic classes that I had to take was we had to prove why 1 was bigger than 0.
How do you prove it?
Oh, there were paragraphs.
Oh.
Yeah.
How do you prove it?
And all I wanted to put was duh.
What do you say to prove to someone that 1 is bigger than 0?
You first have to prove by using a certain theorem. Once that theorem is proved, then you can use that to prove it in another one. Then you can use that to prove it in another one. Right?
Which one has more?
I know.
What kind of stuff do you learn in Calc 3?
Antiderivatives.
Just calculus.
Yeah, it's just more.
My mom told me she took that history of mathematics class because she likes history, but she doesn't like math. So hopefully she could push through it. And she was like, "That's the worst mistake I ever made."
That's miserable. Okay, so this is just like yesterday. I'm telling you one of the factors. I want you to tell me the zeros that are missing. How did we approach these? I gave you a 0 or a factor. I want to know the others. How did we approach them? Synthetic division. Thank you. Go for it. All right, so once we do synthetic division, if we look at it and say, well, I started with x cubed, so now I can start with x squared. So are there factors of 30 that add to get 13? What are they? Okay, 10 and 3, 3 and 10, however you want to say it. So if I set those equal to 0, I get x equals -3 and x equals -10. So by the fundamental theorem of algebra, my highest degree was 3. I got 2 answers here and the one answer they gave me, which is x equals -1. Okay. So then we found our 3 solutions. All right. What if they said in the original problem, here is this equation, here is one of the factors, find the rest, and write it, or they might even say not even find the rest. What if they just gave you this and they said to factor it? Okay. A lot of y'all would be like, well, if I group the first and last 2 together, well, I can't factor by grouping. Can't take out a greatest common factor. Okay, it can't be factored. It can't be factored in a traditional way that we've been learning how to factor, but this still can be written in factor form. We can still write this as y equals x plus 1, x plus 3, and x plus 10. Okay, so don't get thrown off when they say something as simple as factor this, and you're like, how? Okay. Probably kind of like that one problem you were asking me about. It probably said to factor, and now probably that's how you can approach those. Now, this one did not say to factor it, but I'm just telling you if they did. Okay. Try this one. That was quick. Got an email back. They said your account hasn't completely synced. So downtown techs are giving them a boost. And she said that she'll call you down during the second block to help you. And then hopefully we'll get situated from there. One of the videos will be posted so you can watch the previous one.
So if we weren't given a factor, then would we have to use the rational root there?
If I was me, we're gonna go over something like that in a minute. But no, if I was me, yes, you would have to do that, but you won't have to. I feel like there's nothing more gratifying than knowing you did something right when you get 0 as a remainder. You're like, woohoo, I'm doing something right. So we get x squared minus x minus 2. Are there factors of -2 that get us -1? -2 and 1. Set those equal to 0, we get 2 and -1. 1. So they originally told me -10 is one of them, then I found 2, and I found -1. There's my 3 total answers, okay? Pretty and nice when you get to factor. And of course, quadratic formula always comes into play as well, okay? So the question that was just asked, well, what if they don't give us a 0? Do we have to do the possible rational zeros? No, I'm not that mean. I can be if I wanted to, but I'm not that mean. What if I gave you that and I said, find all the zeros? Can you factor it? Like traditional way, can you factor it? No. Can we take out a Grace common factor or anything? No. Do we have a calculator? Yep. So if they do not give you a 0, you can use your calculator. Okay? If they do not give you a 0, you can use your calculator to find 1 or 2 or 3 or however many they want to give you. You will always be given enough to get down to a quadratic. Okay? So in y equals, go ahead and plug this in. By the graph, you'll be able to see what it looks like. I would double check with your table just to make sure that it doesn't like just come really close to it and doesn't actually cross at that point. Okay. What are the 2 zeros your calculator gives you? 3 and -3. Okay, so the calculator gave us 2 of them, but we need 4 total. So this is when we're going to do synthetic division twice. So go ahead and find my 2 missing zeros. It should tell you something, the fact that your calculator only gave you 2 of them. You can't see the other ones. So what does that make you think? Imaginary. Okay. Now sometimes it could be it's out of the window range, that's why you can't see them. But in this case, they are imaginary. So go ahead and find your other 2 zeros. unfortunately on this one, you cannot factor. Some of y'all are still working on that. Again, try to finish yours out before looking up here. So if the calculator only gave us 2, the other 2 are probably going to be imaginary, okay? Which means we have to do quadratic formula for the most part. So if my highest degree was 4, one of my zeros was 3, one of them was -3, one of them is -1 plus I root 7 over 2, and one's -1 minus I root 7 over 2, okay? Again, just kind of doing a little bit more of what we did yesterday. Okay. We'll do one more of these. I know some of y'all are still writing it down. Okay. Let's try one more. Find all the zeros. You can do your table settings because they will cross it exactly. Let me see if I can see it. All right, so after doing synthetic division 3 times, remember if we were x to the 5th, this is x to the 4th, this is x cubed, so this is x squared. So you only end up with x squared plus 1 left, which is nice, because then I can subtract my 1 and take the square root. And the square root of -1 is what? I. Okay, so your calculator gave you -2, 1, and 2, and you found I and -I. There are your 5 solutions. Okay. Any questions on those? Okay. Let's go ahead and get started on our homework.